Okay, so in this video, we are going to start talking about momentum. We're finally getting to the very end of topic 2, which is mechanics. And the very last topic, um, or the very last unit in this topic is called momentum and impulse. And so, once we're done with that, we're going to be moving on to thermal physics, which is a completely different topic. Now, momentum is a unit concerned with things like collisions and things running into each other, and is often used to analyze situations involving um, those kinds of situations. And so you have collisions, with car crashes, with behaviors of a gas, because you can model a gas like you've got a bunch of gas particles colliding with each other. In sports, there's lots of different collisions, whether you're talking about tackling in football or kicking a soccer ball or hitting a baseball. But all of those situations involve some type of collision. Okay, and so again, this is going to be the last unit in topic 2, mechanics, that we talk about. So just to kind of recap, we started off mechanics talking about kinematics, which is the part of physics that describes motion with that regard to what caused the motion. And so we talked about constant velocity, we talked about distance, displacement, all that stuff. And then we started talking about constant acceleration, where we have the 4 different constant acceleration equations. From there, we moved on to talking about free fall, and then projectile motion after we learned about vector components and how to find vector components. Then we did dynamics, which is basically the study of Newton's laws, which describe the cause of motion. And so we now know that it's force, or more specifically a net force, that causes an object to accelerate, which causes its velocity to change. After that, we talked about circular motion and gravity, which describes motion for objects moving not in a straight line. We talked about things like centripetal force and centripetal acceleration and Newton's law of gravitation. And then in the last unit that we just finished, we talked about work energy and power, which basically gives us a different way to solve problems without relying on forces. Because if you have a situation where mechanical energy is conserved, then you can use conservation mechanical energy to solve some problems, or you can use the work energy theorem to solve some problems. Um, and so momentum is basically the last piece of this puzzle. And so just to kind of lead us in there, I want to pose this question to you. Which of these balls would you rather get hit by? And so on the right, you can see we have a bowling ball that has a mass of 7 kilograms, and it's moving to the right with a velocity of 1 meter per second. And down below, we have a tennis ball, which has a mass of 0.07 kilograms, but has a velocity of 100 meters per second. Okay, and so the question is, which of these balls would you rather get hit by? And of course, the answer to the question is kind of a facetious question, so I apologize if you spent a lot of time thinking about that. But the answer is neither one, because they both have a high momentum. Haha. And in fact, they actually have the same momentum, as we'll see in just a second. Okay, so you wouldn't want to get hit with either of these objects for sure. Okay, so let's talk then about what is momentum. Okay, so momentum is basically, I think of momentum as the amount of oomph an object has. Okay, so momentum is the quantitative measurement of how much motion an object has, whatever that means. Okay, and so mathematically we define momentum, the momentum of an object, as the product of that object's mass and its velocity. Okay, now the symbol for momentum for some reason is a lowercase p, not to be confused with an uppercase P, which is the symbol for power. Unlike power, which is a scalar, momentum is a vector. Okay, and so momentum is mass times velocity. And so remember, velocity is a vector. And so if you multiply a scalar by a vector, you get another vector. Okay, meaning momentum has both magnitude and direction. Okay, now based off of the equation we have for momentum, what would the units of momentum be? Okay, so we know how to find the units of something. Basically, you take the equation, you plug units into the equation. So if momentum is mass times velocity, if mass is in kilograms and velocity is in meters per second, then the units of momentum would be kilogram meters per second. Okay, that's it. And we don't give that special name or anything, it's just kilogram meters per second. Okay, so that's what you need to know about momentum. It's mass times velocity, it's a vector, it has units of kilogram meters per second. There you go. Okay, so we can do some basic calculations with momentum here in just a second. Okay, so example 1. A bird with a mass of 2 kilograms flies north at 12 meters per second. What is the momentum of the bird? All right, now we have to be a little careful here as far as establishing a coordinate system. Let's say we have a coordinate system where north is the positive direction. Okay, because when it says the bird is flying at 12 meters per second, 12 meters per second by itself, that's really just the speed of the bird. And momentum is mass times velocity, and so if the magnitude is 12 meters per second, you also need the direction, which in this case is north. And so let's say north is a positive direction. Okay, then the momentum of the bird would be its mass times its velocity, which would be 2 kilograms times 12 meters per second, specifically a positive 12 meters per second, because that's how our coordinate system was defined. Okay, so that would be 24 kilogram meters per second, and that would be the momentum of the bird. Now, what would the momentum be if the bird was flying south? Now, of course, the speed of the bird is the same, but it's not mass times speed, it's mass times velocity. And so if it's flying south, that means it's flying in the negative direction. And so when I get to calculate the momentum, that would be 2 times negative 12, which would be negative 24 kilogram meters per second. Okay, so notice here the negative sign indicates the direction, which is south. Okay, so simple example involving momentum. All right, and just to do one more quick example. Oops. Example 2. It says a bullet with a mass of 5 grams has a momentum of 4.5 kilogram meters per second. What is the speed of this bullet? Okay, so we know momentum is mass times velocity. Now, first of all, it says 5 grams, which is not the SI unit for mass. And so if the momentum is in kilogram meters per second, then I need to convert that to kilograms. And so I would divide by 1,000 and get 0.005 kilograms. Okay, second of all, it tells me the momentum. Now, it doesn't tell me the direction, but if we just assume that 4.5 kilogram meters per second is in the positive direction, then all we have to do is plug in here. 4.5 is the momentum. We have the mass, which is 0.005. We can solve for the velocity, and if it's moving in the positive direction, then the velocity and the speed are basically the same thing because, if you take speed and add direction to it, you get velocity. So v equals 4.5 divided by 0.005. So I'm just going to put that into my calculator really quickly. 4.5 divided by 0.005, and I get 900 meters per second is the velocity. And if it's moving in the positive direction, or really, it doesn't really matter. But then that's also the speed as well, because the speed is just the magnitude part of velocity, as we know from past units. Okay, so 2 very basic examples involving momentum. All right, so that is just to give you kind of like a taste and introduction to what momentum is, and then in the next video we'll talk more about momentum. Okay, this is a relatively short unit, and there's not a ton of really complicated concepts in this unit. So do make sure you're taking really good notes, but do know it is a much shorter unit than the work energy and power unit. So as always, please let me know if you have any questions, and I'll see you guys in the next video.